So we compile the code. Yeah. And see, R2 is a cuboid object, but it is saying R2.volume. Why? Why it's a compile time error? See, for compilation, what is needed? Compiler is not executing the code. Compiler would not know what is there in R2. Compiler is only checking the validity. Okay, depending on the type, as can be determined by the compiler. So when you have said R2, it is looking at the type for rectangle. R2 is the type is rectangle, and then says rectangle doesn't have a volume method. How can it be done? Okay, but we can still, if you want, we can still be invoking the volume method on R2. Okay, how that can be done? Since it has a cuboid object, we can do that, and that can be done by using, how we'll do that? Let's do a casting to cuboid. And you're saying, I know this R2 is going to be a cuboid object. Now here if you do casting, this is so that compiler will not be complaining about the volume method invoked on R2. Fine. And one more thing, let's try this also since we are doing this. Okay, let's try a similar thing. Okay, I think we can do it in the next step. So what we now do is we have our, so we want to compile that, and we said, okay, now it is compiling because we have done the casting, right? Here we have introduced the casting to R2 to be cast as cuboid, and let's call the volume. And if you execute the code, okay, oh, that's going to run also, and it's going to see, oh, R2 volume is, and yes, it's giving the volume according to the same way as it was giving the volume for C1. Okay, so casting was necessary since you are trying to invoke the method. Casting because it is at compile. Fine. So compile time, it's all about the types. Okay, fine. Now on similar lines, someone says, okay, since we are doing a cast and saying you create, let's have a volume on R2, why not on R1? By casting, I can use the method. Yes, we can use the method. So what is there anything wrong here? Line 43, is this wrong? The question is it going to compile or not? Is this going to compile? Invoking method volume on R1. Of course, what we have done is we have cast it into cuboid. So what about compilation? Compilation will have to, and let's see. Okay, if we compile, it's getting compiled. And then if we run, look at the error. So when you try to run, it says, oh, I'm finding that you were casting R2 as a cuboid, but it's not there, right? See, exception. What does it say? Class rectangle cannot be cast to class cuboid. The object is a rectangle object. You cannot cast it into cuboid. When rectangle and cuboid are in unnamed package, that's okay. So at line number 43, right? In the main method test cuboid, main method test cuboid is the class in which there is a method main. and cuboid.java is the file in which line number 43 is where the error is. Okay. And so when it gives error at runtime, yes, it's always going to be on these lines. Okay, clear? So line number 43, yes, that's a place where we did the wrong casting. So if you have an error in casting, it will be an error at runtime. And if you do a wrong casting, rather, this is a wrong casting. But yes, what is there in R1 is never known to compiler. Okay, when execution takes place at runtime, it will know, oh, I don't see the cuboid object here, and the casting to cuboid is therefore a failure. Okay. And we can compile, and now we should be able to run the code. And so clear about method binding which happens at runtime. Fine. So which method is used is decided only at runtime. It is decided based on the object. Object referred from R1 is a rectangle. Object referred from R2 is a cuboid. When you call the area method decided by the object and not by the type. Okay. Right. So this is what we says method binding is done at runtime. Now let's go ahead and make another change. Okay, let's try some other changes also to the cuboid class. Cuboid class, how many instance variables are there? For cuboid, how many instance variables? 3. 2 are inherited, length and width are inherited, height is the third one. Okay, let's try one more thing. Let's try to add one more. Okay, now how many instance variables for cuboid? 4. And it is how many? 4. Which are the 4? Which are those 4? Fine. You say super dot length. Okay, fine. Second one is this dot length. Third one is, okay, see, for length I can say super dot length, this dot length. Okay, super dot width or width. Okay, yeah. Okay, so what happens now? Yeah, so I think see, length can be used in 2 forms. It's there in the anything which is there in superclass is going to be available in 2 forms. This dot that member or super dot that member. Here it has a superclass. Length exists in superclass. Width exists in superclass. Oh, sorry, this one is not there. Sorry, yeah, this fifth one. No, this is not available. We don't have super dot height. There's no height is not in the superclass, so that's not going to be available. Right? And these are the 5 ways of accessing instances, 5 different possibilities of accessing instance variables which are available. Okay, but in total there are only 4 instance variables. How 4 out of these 5? 1 and 2 are fine, they are different, but 3 and 4 would mean the same. So 1, 2, and okay, I was putting 3 earlier, I can still go ahead and say this is still the third one. Okay, and the 4th instance variable is this one. Both of them mean the same here. This dot width and super dot width are the same instance variable. Okay. What we have done here is we have used a variable which appears in the superclass, and therefore we will call this as a shadow variable. We don't say this is overriding variable. There's nothing like overriding for variables. So variables are not overridden, they are just shadowing the variable from the superclass. And so this term, there's a term here called known as variable shadowing. Okay. Fine. What we have done is with variables, don't use the term overriding. Okay, we are using term shadowing. It's a shadow variable which has come up. Okay, okay. So now, yeah. Next thing here, let's look at this constructor part. Fine. There are 4 instance variables, and suppose we would like to try to print all the 4. Or okay, let's see what happens now. And there are 4 instance variables and they all will have the 4 different values. So let me try to print here the 5 different forms which are available. C1 dot length, okay, plus C1 dot. Yeah. Okay, here I think I'll come to this later. Let's just try out within the class cuboid itself. Yeah, within the class cuboid, okay, in the display method, I think I'll update the display method to show the values of the instance variables separately. Okay, this system out is there, but let me add a few. Let's add the displaying variables. Let's say. Okay, so let's try to display the instance variables. Okay, so what are those? Okay, so this dot length and what should I change it to? Super dot length. Super dot width, and we have this will be this dot height. Okay, fine. I said we have 5 forms available, right? So what have we done? Length we have done twice. The width, super dot width is missing. We just updated instead of copying. Okay, see, within the class cuboid, superclass being rectangle, it can use this dot length, super dot length. It can use this dot width, super dot width. Height is the only thing it has added. So for that, we can't say super dot height, but it is nothing but this dot height. Okay, fine. If we don't set a value for a variable, it will be set to 0. Which line? Okay, yeah. So this dot, oh sorry, yeah, this is a, this dot width and super dot width. Yeah. Okay, so length and width as this and super. Okay, height as only this. We are just testing out the various different ways within this class definition cuboid we may be able to use the instance variable. Okay, fine. See, if I just say length or width, it would still be meaning this dot length and this dot width, and it would never mean super dot length and super dot width. Okay. Let us compile. Let's run the code. Okay, displaying instance variables. You can see what is instance variable. This dot length, it is a 0, because this dot length, the length which you have added, the fourth variable, we never did anything to initialize it. Look at the constructor. We'll look at that. Go back to the constructor. Super dot length and this dot length are different, but this dot width and super dot width are the same thing. Okay, and for height, yes, we'll only have this. Fine, clear? Okay, so length, width, and height, 3 things. Yeah. So these are one and the same because they have not been. Now coming to the initialization part, let's see how we were initializing. So we'll have to look at the constructor of cuboid. Yeah, what have we done? When we use super length and width, fine, here super length and width, what is it doing? It's going to the calling the construct of superclass. That means it's going into the construct of the rectangle class, and in the construct of rectangle class, the length and width which is getting initialized, the length is the length available for rectangle. Fine. The length which we have added as an instance variable in the cuboid is not being assigned a value. Okay, that has never been assigned a value. If you want here, you can maybe add that also, right? You can say this dot, oops, this dot length equal to, and maybe how do you want to set it? Whatever the length is there plus 1 or 2, something like that, or we can still leave it and let it remain 0. We know that this is the length which we have added as an instance variable remains a 0. Okay, when not initialized in the constructor, this one, it's a different variable that we have realized. Okay, okay, so now the question arises about variable binding. So now I'm making the statement like we saw for methods, right? Okay, we had seen for method. Okay, let's try for the variables again. In the test cuboid, okay, we have seen area, which area gets invoked, that we have seen. It is decided by the object at runtime and not by the type of the variable. Okay, let's try a similar thing with the variables. Okay, display method is there. I think I can comment out the things in the display now, and whatever wanted to test has been done. Okay, because the output just rolls up. Okay, so okay. Okay, fine. We could see that area method is using this. Now let's try this here. Okay, let's add system.out.println. Okay, and r2.length. We print length on r2. Okay, we can even print length on r1. Anyway, r1 is object of rectangle. So just before the area, we are printing the length. Length is a shadow variable, remember this. Okay. So r1 dot length, r2 dot length, c1 dot length, they are all valid, right? Because rectangle has a length, okay, will be available even for cuboid. Only thing what is happening is rectangle and cuboid, they both have their own length variable. So which length, if it is according to rectangle, it will be the value which is like 7. If it is according to cuboid, the value should be 0. Okay, let's compile. Let's run. Okay, for r1 7, it was a rectangle object. For r2, it was object of cuboid, right? R2 has an object of cuboid, so we were expecting 0. Fine. Whereas later when we did for C1, okay, 754 is the cuboid, but what is the value of length? That is 0. R2 dot length is 7 and C1 dot length is 0. Okay. What it shows is that variable binding is done at compile time. What variable to use is decided at the compiler time. So this is not by the object but by the type. Okay. So here what you could also do here is, we can see now. Okay, so let's try this. So we have done C1 dot length, we get a 0. Yes, we'll do a C1 dot length, but let's do a casting to rectangle. Fine. Okay, so C1 is cast as a rectangle. Fine. C1 is being cast as a rectangle, and then I'm printing, and here, yeah, here the length here is R2, and let me cast it as a casting R2 to a cuboid is not a problem, but because it at runtime it is getting the object of cuboid. But casting R1 to cuboid was a problem because at was a problem at runtime. At compile time, yes, it will take it, but at runtime, if we cast R1 to a cuboid, it will be a error. Okay, let's compile, let's run. Okay, and the initial output, the first one, 7x6 rectangle 7, that is for R1 length. Okay, next one we have R2, it says cuboid of 754. 7 is the output for R2 dot length. Okay, the 0 is the output when we have cast R2 into a cuboid and asking for the length. Okay, so here effect of casting will be there according to the type you have cast it into, the variable. So when you are asking for a variable on an object, okay, it will be according to the type, not looking at the runtime object. So binding for variables is done by the compiler. Which variable it has to use, or that is decided by compiler. Whereas binding for methods is done at runtime. Okay, fine. Here we have done variable shadowing, but it's not a common and neither a good practice. Okay, it's just to see that yes, we should know the rules, what happens here, but we never do such a thing, right? We don't do variable shadowing. Okay, but anyway, for the sake of our example, we have done a variable shadowing. Right? So any questions here? Well, you can have a look at the code. So once again, yeah, let's go through the cuboid class now. Yeah, what do we have in the cuboid class? Added one additional instance variable. We have a additional instance variable for height. Okay, and then this is a shadow variable. Already length is there in the superclass, so this becomes an additional variable and another copy. Yeah, superclass has its own instance variables. They will be available for cuboid. Okay, and cuboid also has 2 more instance variables. So that way, total of 4 variables available. Whenever you allocate an object of cuboid, there will be allocation of 4 integers. Okay, fine. Then the next lines, I have written the comment. Okay, fine. 1 and 2 are super dot length and this dot length. Okay, when the this dot length is remaining a 0 because we have not set up the value. When we are saying super and passing the values of length and width inside the constructor, it is initializing the length and width for the superclass. Okay, you call constructor of a superclass, it's not going to be able to set up anything in the current object. Anything related to cuboid, because the super means rectangle. Okay, fine. Third one, super dot width, length dot width, they both refer to the same thing. And there's no variable shadowing done for it. Okay. And this dot height, right? That's height is not there in superclass, and therefore nothing like super dot height will be there. Okay, the 4 instance variables, that should be clear. And yeah, the constructors. Okay, we have added the methods, and then we have done the overriding, right? Whenever we write a overriding method, it's a good practice to use the annotation called @override. Okay? If you are overriding a method, this is not a mandatory part, but always a good idea to show that yes, this is an overriding method. If there are any spelling mistakes or any such by some mistake which you may not have, you have overseen, right? That way, in that case, the compiler would be able to point out the error. Okay, So always good idea for your overriding methods to say @override. Okay, annotate. When we are calling it as annotation, right? Annotating the method, right? So yeah, you can have annotations for anything. One more thing, that modifiers, right? Okay, here we don't have other modifiers. Yeah, we haven't used them. Anyway, see, later we'll talk about it. Yeah. So any questions so far? Yeah. Method overriding, variable shadowing. But you need to try it out. Okay. So let's compile the code. This is compiled. Any questions? Yeah. But I would request that you try at least whatever is fine. This code you should at least be compiling on your own, executing, and seeing the output, and then you can always make those modifications and try again and again. Right? So find time to do this. Okay. 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 Now, the next thing what we can do is let's have some additional exercise. Okay. So let's start with some more exercise related to defining a class, and then we can go for the inheritance also. Okay. So this was rectangle and cuboid. Okay. What we have seen is rectangle and cuboid. Now let's have an exercise where we would like to create a class to represent a bank account. Okay. Fine. We may call this as a class called account. So we want to have a class called account. Okay. So if there is a bank account, yeah, what is the information which should be there separately for each object of the bank account? The minimum information. Every bank account has a account number, and there should be the name. Fine. Every bank account will have a name, and there will be information about what balance he has got. Okay. Account has a account number, name, and balance. Okay. Fine. So now I want you to do this on your own. And initially do it on your own, then I'll tell you how it is to be done here. And we'll keep one copy here, but here in this exercise, I would like you to try it out first. Okay. Fine. So idea is clear. We want to have a class called. Okay, let me put the statement. Okay, so we have the exercise. So what's the exercise? And to represent the bank account. Okay, fine. Okay, so the idea is I'm indicating that you need to have 3 instance variables. Okay. And so you provide for the getter methods. When I'm saying getter method, what does it mean? Oh, we will have account number as a instance variable, then provide a method called get account number. Okay, you will have name as a variable, therefore you have a method called get name. Okay, fine. So we need all of those variables, right? Instance variables. Yeah. Have a constructor with 3 parameters. Okay, what are those 3 parameters? Account number, name, and opening balance. Okay, so have a constructor with 3 parameters. Okay, add methods for displaying 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 details like account number, name, balance, so separately, right? Can be there. What else can be there? So you have methods for displaying. Any other method you feel? Yeah, okay. It should have 2 important methods. Okay. So have a method called deposit. Okay. Okay. Okay, let's see what's the signature we want. So we want it to be something like this: public void deposit. Okay. The type for the amount and the balance, what can it be? Maybe we keep it as long. Balance we can keep it long, and amount also. So amount being taken as parameter. So something like this. This is the kind of signature I want for the deposit method. And so also add a method called withdraw. Okay, so it will be like this. Public. Now this one returns Boolean. Takes amount as a parameter. Why the Boolean? Okay, what will the deposit method do before that? Yes. Okay, that I think we understand, but yeah. And what about the withdraw method? Yeah, the withdraw method will check if it has to return a Boolean value. So here, if it is having sufficient balance, the amount being withdrawn is not more than the balance. In that case, you can go ahead and go ahead, update the balance and return true. So do not update the balance if you don't have the balance. Okay, and return false. It couldn't be done. So we are returning a Boolean value, true or false, because withdraw method can fail also. Right? You don't have money and you're trying to withdraw. So that's the kind of exercise we have, right? Okay, fine. So this is the exercise. So request you that you try it out first, and then I'll do it later. Okay. So at least one class you have to create on your own first. Okay, so we have this account exercise. That's the next thing, and okay, fine. Fine. We can go ahead with the next thing in the agenda, and which is about let's revisit the relation between rectangle and cuboid. Earlier, when we started with this cuboid class, I did mention that this is not a proper case for inheritance. Right? The reason? Yeah. Here we are trying to say that cuboid is a rectangle, which is not correct. Cuboid is not a kind of a rectangle. Right? See, if you are saying, I want to go for subclassing, keep in mind this thing first. Do not look at, oh, I have common instance variables, so length and width is there also, and I will be able to inherit. Fine. I will not have to declare length and width. No, that's not the criteria for deciding inheritance. Fine. So this thing, whatever we have done, yes, it's a faulty thing. Okay. But anyway, we do it as an exercise, whatever, fine, just to see and understand the syntaxes related to. So we did it to understand this, super, the extends keyword, all of those things. Okay. Fine. So from that point of view, yes, the exercise is relevant, but otherwise, the way relationship between rectangle and cuboid is there, it's a different kind of a relation. It's not the inheritance relation. The inheritance relation is decided if we find the is a word applicable to it. So if we could say cuboid is a rectangle, no, it doesn't sound good to me. Okay, it doesn't sound good to me, and therefore it shouldn't be taken as a subclass. Go for subclass only if you feel that if I say is a, right, it sounds good, okay, then fine. If someone says car is a vehicle, it sounds correct. So if there is a class vehicle, you can go ahead and create a subclass called car. Okay, so first criteria for deciding inheritance is the is a relation. Okay, not I want to save some coding by so I won't have to have the variables like length and width again here. Okay, fine. There is a different way to manage that part. Oh, rectangle has length and width, that's fine, but we can say we can have a different kind of relation between the rectangle and the cuboid, and that relationship is what we call as has a relationship. cuboid has a rectangle, and cuboid has a rectangle and height. Like we are saying, rectangle has length and width, right? We say rectangle has a length and width. Similarly, we can say cuboid has rectangle and height. Okay, fine. So if we say cuboid has a rectangle and a height, yes, then it can be. So the relation between cuboid and rectangle is nothing but has a relation. It's not is a relation. Okay. So from object-oriented point of view, fine, object-oriented designs point of view, we have these two relations. When we say is a, we say this is nothing but case of inheritance. When someone says we have has a relationship, we call it as composition. Okay, we go for the case of composition. Okay. Fine. So here we will go for composition. Okay, so yeah, last time I think we started with inheritance, right? Uh, so we looked at inheritance, and earlier we had created a class called rectangle, and for the purpose of inheritance, okay, what we have done is we have used the class. Let's see what was done. Yeah, okay. Uh, yeah, what we did was we have created a class called cuboid, right, as a subclass of rectangle, and we added some methods over there, right? So we did both the things. We had new methods as well as we were overriding methods from rectangle in the cuboid class. Fine. I think I'll open those classes also. So earlier I think we had this class rectangle on something like this, right? Class rectangle with variables, uh, instance variables, class variables, and then we had the static method as well as some regular methods, right? We did method overloading. Okay, we also had the initializer block and the class initializer block, and we also have constructor which were overloaded, right? Later, I think for convenience sake, right, we also added a method called display. Okay, fine. Test rectangle. Fine. So this was just to demonstrate what we can do if we have a class called rectangle, how we can use it, the different things which we can do with a class. Okay, so this was done earlier. Okay. And then we said we would like to go for inheritance. And, okay. So cuboid as a subclass of the rectangle class. Okay, this is what was done. And so we started like this. We said we should add one more. So rectangle had two instance variables and they would get inherited here in the cuboid class, and we wanted one additional uh, variable, and for which we just introduced a only so we introduced another instance variable called height. Okay, and accordingly, yes, we also have seen that since our rectangle class does not have a no argument constructor, okay, it was required that we should have at least one constructor in our class, okay, which would directly call super, right? Otherwise also when you write a constructor in any class, okay, a call to the constructor of superclass is always implied. Okay, there's always an implicit call to the constructor of superclass by using super without any parameters. Okay, fine. So any constructor always uses constructor of superclass first. That's the first thing, right? Okay, and then yeah, what else we had done last time? We added a method called get height. We have added the method called volume, I think, yeah. Okay, a volume initially we had written with this dot area multiplied by this dot height, but then when we saw the results, what happens when we override the method area? Okay, fine. So once we override the method area, we wanted to have a different kind of an area method uh, for cuboids. Okay, in that case, the volume method had to be updated and we started using the keyword super. Okay, so we have seen one use of super. Okay, so what is the use of super? Also, we did some overriding because the display method also got inherited from rectangle class, and then we had to have our own version of display. Okay, fine. Fine. So any questions from earlier sessions? Yeah. Any questions so far? If you have tried some of the things, you would have got some questions. this code was available from Git repository. When you could try it. Okay, you should actually try it regularly, right? At least run this code, look at the code, then make your own modifications. Okay, and try to understand, try to add some of your own things to it and test out. Okay? And then you should have questions at least, right? The new things which you try out. No questions? Harshil, Yash? Any questions? Yeah. Okay. And, I think, see, like everyone should try. Okay. And just I'm putting the code in, that's not enough. Okay. You have to actually try it out practically. Right? And then, yeah. I mean, it's better, like if you try, you will have some questions of your own, right? So, yeah. Okay. Fine. So let's proceed then, right? So what we have done so far is we have a subclass. Okay. For creating subclass, we use the keyword extends. Okay. And then we have added methods. We have added an instance variable, fine, which was height was added as an instance variable for cuboid. Get height method, just like other getter methods, fine. Another additional getter methods. We would have inherited the get length, get width, area, all of those methods, right? Fine. So in a subclass, remember this, in a subclass would either inherit or override methods of a superclass. Fine. So in our example, yes, it was earlier, it was only inherited, but then we had done the overriding. This line 25 here, and this is nothing but overriding the area method of the, as it was available for superclass. Okay. Fine. So we have seen what we call as a method overriding. Okay. Fine. In this example, we have seen method overriding. Fine. Okay. Area method for rectangle, it's defined in the rectangle class. Okay. Fine. And it was working on objects of rectangle, and since it works on objects of rectangle, cuboid being a subclass, it would work on objects of cuboid also. Okay. Fine. And then, yeah, then what happened? When it's possible always to override methods which are there in the superclass. Okay. So area method here has been overridden. Fine. But once we override, okay, if we have used this dot area anywhere, right, in our code, see, if you write simply area, it would also be this dot area. Okay. And if you don't mention for a non-static method, if you don't mention which object it is to be invoked on, fine, in the subclass, it would always be considered as this dot, so current object only, right? Okay, this dot area, that's how it will be considered. Okay, fine. So yeah, I mean, this is related to okay. So we have seen this in the, after the get height, we have another method. Yeah, volume method is where we have done that, right? Yeah, the volume method, right? So here, if you write simply area, right? If I remove this part, fine, then it would have meant only this dot area. Fine. If I don't prefix with super or this, it would have actually meant this dot area. Okay. Fine. So method overriding and use of super, that's something we should have understood. Fine. Also, I just put it out last time. Fine. Last time I also explained, I think, about this, that if you have a class A, okay, and let's say it has three methods, right? M1, M2, M3 are three methods of class A, and class B is overriding method M1 only. Okay, fine. Within class B, okay, the methods M1, M2, M3 are available. Any method which is there in the superclass is available in two forms. Okay, you can either say this dot M1 or super dot M1, this dot M2, super dot M2. Anything which is in the superclass, you can use this dot method name, super dot method name, and both of them would mean the same till you override a method of the superclass. Then the difference between this dot method name and super dot method name would only arise when we have overridden the method. Right? So when you override the method, then this dot method name changes to whatever is in the current class. And super dot method is about the method as it is available for superclass. Okay. Right. And if you're not saying this dot M2 or super dot M2, it would mean this dot M2. Fine. So if you don't prefix with this or super, just say M2, it would have meant this dot M2. Okay. Fine. The other point in this place, what we explained was for the class C, okay, since M2 is not overridden, if he says M2, the version of which what he is using, or even if he says super dot M2, he might say this dot M2, super dot M2, it would mean the same. Or sorry, here M2 is being overridden, yeah. So if it is, he's saying this dot M3 or super dot M3, it would have meant M3 which is defined in the class A. For objects of class C, okay, if someone invokes the method M3 has not been overridden anywhere, okay, it would have meant M3 which is as it is defined in the class A, fine. But if he says M2, he will have M2 as defined for class, as available for class B. You in class C, he will not be able to use M2 which is available for objects of class A, because M2 is overridden in B, the direct superclass, and there is nothing like super dot super. Okay, you can't say super dot M1. Okay. Okay, fine. So now we have seen this with methods. Fine. Let's see. Fine. Let's look at it with variables also, right? Then we'll see something about. We'll try to test the cuboid class, okay, along with the rectangle class, both the things together. Fine. We have the test cuboid class, okay. Okay. Now in this class, let's write code, compile and run this and check the things here. And last time we only did this, right? Okay, let's declare variables of cuboid and rectangle. So C1, C2, R1, R2, that's what we have defined. And C1 we initialize to a cuboid of 754. Let's initialize R1 and R2 also. R1 equals, and let's create a rectangle object of 7 by 5, okay, and R2 equals new rectangle object of, no, not rectangle, yeah, can we assign cuboid to R2? Okay, cuboid is a subclass and therefore it can be, it's a subtype of rectangle type, and therefore R2, which is a variable of type rectangle, can always have an object of cuboid. Okay. Fine. So we have created a cuboid object of 754 for R2. We have created for C1 also a cuboid object of 754. But they are two different objects and they are not the same object. Okay, fine. We can display, that's fine. We can, after each creation, maybe we call display. Okay, so we have displayed what they are. Yeah. Now, yeah. So we are looking at volume of C1. What about calling a volume method on R2? Or okay, let's call the area method first. Right? So let's see. This is R1.display, and let's then print. So we are now testing the area methods. Okay, println area of R1 plus. Okay, so we print the area for R1 and we do the same with R2. Okay, fine. Let's also print for okay, area of C1 dot area. Okay, and then of course we are just printing earlier printing, so let it remain. So we'll be printing. So the question here is, before I compile and run the code, okay, the question is related to what do you think is the area here? R1 dot area. Is it length into width or length into height? The idea is, will it go by the rectangle definition or by the cuboid definition? R1, R2, they are of type rectangle. The type of the variable is rectangle, fine. And we are invoking the area method on the object of rectangle in case of R1. When in this line, fine, line 42, we are invoking area method of rectangle. Fine. In case of, in this line 45, okay, we are printing area method on R2. Okay. Fine. R2, what is the data type for R2? Rectangle. What is the object in R2? Cuboid. And so the question arises, what will happen to the area method? Which area is going to be used? Will it be the area method as defined in the rectangle class, which is nothing but the type of the variable R2, or is it going to be the area method as defined in the cuboid class, which is nothing but a cuboid class is nothing but R2 has the object of cuboid. So is it going to go by what object R2 is having, or is it going to be by what is the type of the variable? Okay. Fine. So the question is more about this particular line. So what do you think is the output? Yeah. Going by area rectangle or going by cuboid? R2 dot area. According to rectangle or according to cuboid? What is the guess? Then let's compile, and we are compiling cuboid.java. Okay, it compiled successfully, and so we got the class cuboid and java -cp /bin, and we will have test cuboid. Okay, so what are your guesses for R2? What is it? It's according to cuboid, right? C1 and R2, yes, they have the same dimensions. Oh, when we call the display method, again you can see even the display method on R2 is according to cuboid. And you can see this line. This line is nothing but display method on R2, and then the area on R2. Then we have display on C1. This is area method of C1. Then clear? Let's check what would happen. How do I get the area method on R2, which is according to the rectangle class? So someone might think, oh, let's try to cast it as a rectangle. Okay. It's being used like a cuboid. Oh, I would like to use it like a rectangle. Okay, so you can do this casting R2 as a rectangle and then say, let me call the area method. So now what should be the output? This area method, what is the output it is going to give? According to cuboid or according to rectangle? This will be according to rectangle. Okay, let's check it out. It's still going by cuboid. See, one thing, the difference is about runtime and compile time. Right? Casting, when you do a casting, it's about a type, changing the type. Right? Types are applicable at compile time. At compile time, it has to do the checking. Oh, whether area method is available for the type rectangle. Area method is available for the type cuboid or not. But which method will be used, whether the area definition of area according to rectangle or cuboid, is not decided at compile time. Okay, it is only decided at runtime. When we use the term that method binding is done at, and for methods the binding is done at runtime. There is no binding at the compile time. So compiler is not making a decision on which area method to use. It's only checking whether area is available or not. And it's not going to decide, oh, the rectangle's area definition has to be used. At runtime, what is R2 referring to? I find an object of cuboid, and therefore the area has to be according to cuboid. Okay, you do casting, but that's applying to the compiler. It's not applicable to the runtime thing as far as method invocation is concerned. So whenever we invoke a method, fine, okay, if there is an overridden method or anything, the method which will get invoked is according to what is available for the type of the object which is being referred from that variable. Fine, it doesn't matter, the type of the variable doesn't matter to me. Type of the variable was rectangle, you may try to do casting, no way. This is a cuboid object and therefore it has to behave exactly like what cuboid does. R2 is a cuboid object. Fine. Okay, now coming to this point, on C1 I can invoke the volume method, right? What about R2 dot volume? Yeah. What about R2 dot volume? Let's check this. Oh, R2 is a cuboid object, right? Okay. So I think we can remove the casting here. Right? There's no effect of the casting. Okay. So just removing the casting which we did. Okay. So this is like this, right? And then let's try so something similar to trying to print the volume, right? We did volume for C1. Let's do the volume for R2. Okay, fine. So what do you think? If I say R2 dot volume, is this okay or anything, any problematic thing? R2 dot volume, what will be R2 dot volume? Okay, let's check it out.